Yes, so I was telling this to find out the settlement. 10 ton per meter square is the reduction in bearing capacity due to saturated state for 1.6 meter depth of the soil. So we can find out the settlement, of course. 1 kg per centimeter square is the change in pressure multiplied by 1.64 meter multiplied by 100, that is in centimeter, that is how much depth each of soil is saturated, multiplied by 3.62 divided by 100, that is soil properties we will take for sand, of course. So we can find out the settlement for sand. Settlement should be less than 40 mm. For clay soil, settlement should be less than 65 mm. So if it satisfies this settlement, then permissible settlement, of course, then we can say that our structure is safe. Now 10 ton per meter square is the reduction in bearing capacity. So for that we have to provide more depth of foundation for 10 ton per meter square. So which can be found by Rankin's formula. 10 ton per meter square divided by 1.85, that is the unit weight of soil, multiplied by 1 minus sin phi by 1 plus sin phi whole square. Phi is taken as 30 degree. So 0.6 meter is the depth of foundation that is required, which is more. 0.6 more depth of foundation should be provided. So suppose 1.2 meter is the depth of foundation for pavement. So we have to provide 1.2 plus 0.6, that is 1.8 meter. That is considering if there is water logging on the pavement up to 2 meter. Then our pavement will be safe, that is compared to this settlement. When we can find out this 0.6 meter depth bearing capacity of the soil, of course, which can be found, that is 1.85, that is unit weight of soil, multiplied by 0.6, that is depth of foundation, that is we have provided more, multiplied by 1 plus sin phi by 1 minus sin phi whole square. Phi we can take 30 degree. So that is improvement in this bearing capacity of soil, that is 10 ton per meter square we will get when we have provided 0.6 meter more depth of foundation. So 20 ton per meter square is required, and we are after improving the points, more depth of foundation of 0.6 meter depth, we have achieved 10 ton per meter square more bearing capacity. So 10 plus 10, that is 20 ton per meter square we have achieved. So it can take the load coming from top in case of if there is water logging. In case of building also, we have to, that is construct the building, we have to think over that water, because penetration of water is a very dangerous agent, of course, in a structure, of course, that for deterioration of the structure. Due to penetration of water, deterioration in the strength of the structure will take place. So in case of building also, we have to think over that like this. Suppose water logging is 2 meter around the building. Penetration of water will take place 0.6 into 2. That much depth of soil will be in saturated condition. So 20 ton per meter square is the required strength. So after saturation of some depth, that is 0.6 into 2, that is 1.2 meter depth of soil will be in saturated condition. We can find out the settlement by using that formula. Just now I have told you, and we have to check it is within permissible limit or not. That much reduction we have to provide more depth of foundation. Then structure will be safe. Whatever a structure is made on the ground, it should be checked with respect to the settlement parameter, of course, and we have to provide more depth of foundation for that much reduction in bearing capacity of the soil due to saturated state of the soil. In this way, the structure will be safe. Now, in rainy season where heavy rain is occurring, in mountainous region, of course, landsliding is taking place. I have told that how this landsliding will take place. Suppose 400-meter height of the mountain, so we can find out the weight, that is 1 meter length, 1 meter width, multiplied by 400, which is height, multiplied by 2.64, that is unit weight of this rock. We can find out the load. So whatever that is, in this case, shear strength will be taken into consideration. So whatever that shear stress is coming due to this load, that is load we are knowing, load multiplied by height, that is tangential force, that is along the height, that load divided by 400 into 1, that is length, we can find out the shear stress coming from top. So that in bottom, that of course heavy rain, soil will be in very saturated state, of course, which shear strength is reduced by 80 to 90%. Suppose 1.8 kg per centimeter square is the shear strength of the soil, 90% is reduced. So that much shear stress coming from top, that is due to the weight of this mountain, that if it is more than the shear strength of the soil, which is 90% reduction in, that is 1.8 kg per centimeter square of 90%, that much is reduction. So it will, that if it will not sustain that the shear strength, that is if load, that is shear strength due to load is more than the shear strength of the saturated soil, then landsliding will occur. Remedy, we can provide retaining wall, that is for proper taking appropriate thickness of the retaining wall along the mountainous area, so that landsliding can be prevented. Now in case of dam, that is for flood protection, of course, we have to, that is that time we have discussed, that is thrust of water, that is it is very much more, that is along the bank. Suppose 5 meter is the depth of water, suppose, so it will that exert pressure, that is due to a standing water, which is WH square by 2. W is unit weight of this water. Of course, there will be velocity. In flood case, 1.2 d we can take. D is depth of water. So WVA square by twice E, we can find out the lateral thrust due to the velocity of water. So adding these two, that is due to a standing water, thrust due to a standing water plus velocity, if it is less than the bearing strength of the soil, that is in wet condition, of course, why a covering of the soil will take place? When this bearing strength is more than this thrust, then scouring will be there will be no scouring of soil. If thrust of water is more, then the bearing strength of the soil, then scouring will take place. So, in case of embankment, it is made on the along the river, that this should be checked if it will sustain that much thrust of water, the bearing capacity of the soil, then it is okay. If it is not, then we have to provide, that is stone pitching, etc. That is in case of reservoir, that is dam. We are providing, that is stone pitching is to be done along the length of the bank, so that it can sustain the this thrust of water, of course, due to velocity as well as standing water. So for flood protection, we can do this remedial measures, we can adopt it. So in this way, that we have to think over that this thing, that is for flood protection as well as landsliding, as well as this waterlogging, etc. These things, that is whatever structure is made on the ground, that we have to think that proper thickness, of course, it should be found according to the tensile strength, that is in case of pavement we have seen, and we have to that see that it should be checked with the settlement. Whenever reduction in bearing capacity of the soil due to penetration of water, then we have to provide more depth for this much reduction of this bearing capacity of the soil. Okay, thank you.